We're going to have a look at how to find the inverse for a function f of x. Now, all we need to know is these 4 steps. If we follow them, we're going to get to the right answer. So the first step is telling us to change our f of x into y. This will help us rearrange the equation much more easily. Second step, that's telling us to change all our y's into x's and all our x's into y's. So every place we see a y, it becomes an x, and every place we see an x, it becomes a y. Third step is telling us to rearrange this equation into the form y equals. We need to isolate y. So why don't we minus 1 from both sides? And the fourth step is asking us to change this f of x back into the f notation. So now y equals the inverse. I'm going to flip it as well. And that's our inverse there, x minus 1. Let's try a slightly harder example. So step 1 is asking us to change our f of x into y. Second step, we're going to switch our y's into x's and our x's into y's. Third step, we're going to rearrange for y. So let's multiply both sides by y. Let's bring the y's order onto one side. Factorise out our y. Finally, the fourth step is asking us to change that y back into the f notation. So we've got f to the minus 1 equals 2 over x minus 1. And that's our answer there. Example 3. So let's have a look. F of x, let's change that to y. Second step, let's change our y's to x, x's to y's. Third step, let's try and rearrange this for y equals. A bit tricky, but hopefully you can notice that we can complete the square here. If we complete the square, we're only going to have one y on this right-hand side, which is exactly what we want, because then we can rearrange it. So to complete the square for this, hopefully you know how to do that. We're going to get y plus 1, divide this coefficient by 2, squared minus that b over 2, all squared. We're going to get minus 1 minus 1. Let's bring that 2 to the other side. We're trying to isolate our y now. Let's bring this squared to the other side. Don't forget, when we do that, we get plus minus. And finally, we're going to get y equals minus 1 plus minus square root x plus 2. Let's take a bit of a break now, because we want to explore what this plus minus means and whether it's correct. To do that, let's first look at our original function, this x squared plus 2x minus 1. What does the graph of that look like? It would look like this. It would have a turning point at minus 1, 2, just here. Now, this isn't a one-to-one mapping. A one-to-one mapping means that for every value of x, there's only one value of y, and vice versa. But this isn't, because we can see if we plug in y equals 0, we're going to get 2 values of x here. If we plug in y equals 1, again we're getting another 2 values of x. So it's not one-to-one. That would be there'd be many values of x to get one value of y. So that would be known as a many-to-one mapping. However, we can still find the inverse of this function. We just need to modify it slightly. So if we have a look at Desmos, what we can do is we can put in a domain. So we can use curly brackets here to say that we want x to be greater than or equal to -1. And this is going to knock off all this other part of the graph so that now we do have a one-to-one mapping and we can find the inverse of this graph. So for every value of x, there's only one value of y. For every value of y, there's only one value of x. So likewise, if I plug in my y equals 0, there's only one value now. If I plug in y equals 1, there's only one value of x now. So this is brilliant. The second thing you should know is that we know now how to find mathematically the inverse, but it's also good to know what it means graphically. So to find the inverse of a function graphically, all we have to do is plot the line y equals x, so that's this green line here, and we just need to reflect our graph in this line. So we're going to get something that looks like, well, let me have a look, that's one diagonal square past it, so it will kind of start there and it will go like that, and it's going to hit that point there, and then it's going to come this way. Now here are my two functions, my plus square root and my minus square root. Let's have a look at which one is going to be an accurate reflection in that line y equals x. Well, that looks pretty spot on. That's exactly what I was looking for. Let's have a look at what this one looks like. That's not the same. That would be a reflection of that part that I knocked off, I truncated. So that would be the inverse if I did x is less than or equal to -1. But since this is our domain, we're going to go with this is our inverse, the plus square root. Let's come back to our final step. We're going to switch our y to our f -1 equals -1. We're going with the plus x plus 2. Now to plot the inverse graph, we know how to do that. We're going to first make sure we plot our y equals x line, this green line. You can do it as a dashed line if you like, to remind you that it's acting as a mirror. And then we can plot our inverse, and just make sure you label them all. So this would be our original function here, our f of x. This is the line y equals x, and this is our inverse.